So today I'm going to talk to you about the science of authenticating Angular applications. So a little bit about me. My name is Maida. I run a couple of DevRel teams at an identity and access management company called Isreal. I'm a Google developer expert in Angular, and I also run an Angular meetup in Michigan. Now this is a tweet that I saw towards the beginning of the year. I think it sort of embodies a lot of developers' experience with authentication. So you come onto a project, they say you're going to work on the authentication, you're like, yes, and then it looks something a little bit like this. It would help if I turn that on. Yep. So what I want to do is I want to demystify this a little bit. I'm going to do, for the first half of the talk, a little bit of an introduction to the different types of authentication that we use in web applications. And then for the second half, I'm going to talk about application of those principles in Angular. So I'm going to start out with cookies. Now, cookies are traditionally used to secure traditional web applications. So I'm talking about back-end apps. This is things like apps built with PHP or .NET or maybe Node. And the flow for this looks something like this. We have the user looking at their browser. And then on our server, we have our back-end application, and maybe we have a database with sensitive data in it. And the user is going to submit their credentials to log into the application. These are going to be sent to the back-end. If everything checks out, then the user is logged in, and the server is going to set a cookie. This cookie represents the user's session. It means the user is authenticated, and the application knows about the user and their session. Now, on any subsequent request for pages from the front end, from the application, then when there's traffic to the domain, then the cookie is going to be attached by the browser and sent to the server. And this is a browser thing. The browser sort of does this on its own. Once that happens, cookie is valid, everything's good, then sensitive data can be sent back to the browser. Now, if the cookie is expired or there is no cookie and request is made for sensitive data, then what's going to happen is we're going to get a 302 redirect status. What this is going to do is it's going to tell the browser to do a full page redirect to send the user somewhere where they can re-authenticate themselves. Once they've done that, then we can send secure data again. Now, in Angular, we build single-page applications, and we frequently see token-based authentication for securing single-page apps, and it's going to look a little bit different than cookie-based auth, and it looks like this. So once again, we have our browser, and then we have our application. When the user navigates to our app, then the app is compiled, downloaded, and then it runs in the browser itself. And then we get data traditionally, usually from an API. We also have this thing that's called an authorization server, and really what that is, it's a fancy name for a set of endpoints whose intent is to issue tokens. Now, when the user submits their credentials to log in, then a token can be issued, and we're going to send that token to the API with any requests that we make for data. Now, the API is going to verify that token with middleware. And if everything works out, then data can be sent from the API back to the application, and the app's going to consume this. It's going to be in the format of JSON. So here's a question. Why wouldn't we just use cookie-based auth with single-page applications? Now, cookies only work on the domain of the application. So if everything is on the same domain, your API and your front-end app, then this is going to work. Cookies will work for you. But many single-page applications these days call APIs that live on different domains or different subdomains. And if this is the case, or if they don't do so already, they may need to do this in the future for scaling. Right? So if your API and your application are on different domains, then the same session cookie is not cross-origin. It's not going to work across both those domains. So this isn't going to work. Now, maybe that's not your architecture. Maybe you do have everything on the same domain. And if that is the case, you are not calling any third-party APIs right now, and you're pretty sure you won't need to in the future, then you actually should consider doing your authentication on the back end and serving your authentication routes out of the back end, and then just securing your whole ecosystem with cookies. There's nothing wrong with doing that, and in fact, it's somewhat recommended if that's your architecture. One thing you want to keep in mind if you do this, though, is that when an app uses cookie-based sessions, as in our traditional scenario, then when the user tries to access a page, if they're not authenticated, remember the server is going to return that 302 status, and it's going to redirect the entire browser to somewhere where the user can authenticate so that a cookie can be generated again. Right? Now, single-page applications request pieces of data as JSON. Right? So if our cookie is expired in this case, then the response we're going to get is still going to be that authentication redirect, that 302 status. So in our single-page app, we're going to need to add some kind of logic that tells our application how to handle that scenario. So if it's a 302, when we're expecting JSON, then we should go and re-authenticate. Now, there's nothing wrong with doing this. You can do that. But if you are in a scenario where you know you're going to need to scale in the future, or you already have APIs that live on other domains, then token-based authentication is the choice for you. It's what you're going to want to use. Now, one thing that I want to talk about when we're using tokens is the storage of them. Because tokens are very powerful artifacts. They give people access to your API, right? So here's something kind of important. You shouldn't store sensitive data like tokens or sensitive user information in local storage, because local storage has a distinct lack of data protection. Now, the thing is, local storage is easily accessible to any JavaScript that's running on your page. So it's vulnerable in a number of ways. If a malicious script is injected on your page, if you have a compromised third-party script, then that can read your local storage object and steal anything that might be in it. Now, sort of on the flip side of that coin, a malicious script could inject bad things into your local storage, which could potentially make it somewhat of an untrustworthy source of information. And then finally, all local storage is shared within a domain. So if you have multiple applications that run on the same domain, then they all have access to that object. And if you want to have authentication for separate applications, then it's not sort of a good idea to put all of their different tokens into the same place, right? Now, the most common reason that we store tokens in local storage in the first place in single-page applications is for session persistence, right? So if the user leaves the application, we lose all the data in the application, all of its state, and they come back, we want to have a way for them to still be logged in, so they don't have to log in again, right? That's why we store it in local storage. But what we should do instead is we should store the sensitive data in application memory, but we still want that session persistence, right? So the thing is, if you have an authorization server, when the user authenticates, the authorization server, what it's going to do is it's going to set a cookie. And this cookie lives in the browser, and it actually represents the user's session. So if we refresh the browser, we're going to lose all that local state, single-page app reloads, and we don't have our token anymore. But what we can do is something called check session. So we can check to see if that cookie from the authorization server is still valid. Now, note that this isn't a cookie that's going to be sent to your API. It's not a cookie that has sensitive data in it. It's just saying whether or not the user has an active session. And then if it is valid, then we can actually request new tokens silently without prompting the user for credentials. So super helpful and more secure. Now, I want to also talk about some guidance for token-based authentication with single-page applications. I'm going to start by talking a little bit historically. So in 2012, when the OAuth 2 specification was initially adopted, single-page applications weren't mainstream yet. For example, AngularJS showed up around this time, but it didn't really become popular until 2014. So this was an era where most applications that were for the web ran on the back end. So given that, the guidance that existed at the time of OAuth 2 adoption looked something like this. For browser-based apps, OAuth 2 for authorizations said that you should deliver tokens to the browser in a hash fragment in the URL. Now, there's some security risks that are inherent to doing this. The token is vulnerable in a number of places when done this way. So it's vulnerable in the redirect URI. That URL that the token gets attached to with the hash fragment. If somebody were to be able to tell the authorization server, no, send it to me instead of your application, then you've just given your token to somebody else, right? It's also accessible in the browser history, right? So that browser history API is available to any JavaScript running on the page. Cross-site scripting, some attack like that could take it right out of there. It's also potentially accessible in the referrer header. So if you have an attack where a malicious page ends up being requested right after authentication, then that page can also grab your token out of the referrer header. And then finally, the app doesn't naturally on its own have a way to really check where that token is coming from. It shows up in the URL, we grab it, we assume that we can use it and it's safe, and we plug it into our app. So authorization server companies like Auth0, like Okta, things like this, and app developers mitigate these security risks manually right now. And I want to stress that there are no new threats to this approach. So the same mitigations that we've used for the past 7 or so years will continue to work right now, but really, because modern JavaScript is eating the world of web apps at this point, it's just time for new best practices. It's time for new recommendations. So the IETF, the Internet Engineering Task Force, has implemented new best practices. I'm going to tell you about them. So it's not actually super new. It's the same approach that's used in mobile applications. So if you've done mobile app development with authentication, you might actually be familiar with this already. It's basically a flow where we're going to exchange a code for a token. Now, I'm going to go through this kind of quickly, but don't worry too much about it. The first thing we're going to have to do is on the front end, we're going to have to create a random string called the code verifier. And this is a high entropy random string. And then what we're going to do is we're going to compute another string from that first string, from the verifier. And the second computed string that we create is done with a hashing method. And the hashing method is called code challenge method. The thing that we get out of it is another random string, and it is called the code challenge. And then what's going to happen is when a user logs in, we're going to send both the credentials and the code challenge to the authorization server. The server is then going to generate a code, and it's going to send that code back to the browser, which it can receive in a hash fragment, because interception of that code isn't actually dangerous. If somebody were to get access to that code, it doesn't grant them anything. They could send it to the authorization server or something. Authorization server would be like, OK, you sent me a code, but that's not all of what I need. Because once we have that code, then the code and the code verifier can both be sent to the authorization server together. And what's going to happen then is the authorization server is going to independently verify this. So it's going to calculate the code challenge from the verifier itself, which we already did in the app on the front end, remember. And it's going to make sure those challenges match the one that the app sent before. Now, if the challenges do match, then a token is issued, and it's sent back to the application as in a JSON object. Now, with this scenario, all of the mitigations for security risks that we were taking in order to protect the token being in the URL, we don't need any of them anymore. Now, this was kind of a lot. Like, there's a bunch of things. There's a hashing method, and there's a couple of random strings, and there's a code, and blah, blah, blah. But one of the sort of neat things to remember is that SDKs can actually do all of this work for you. So if you are building a brand new application, you need to add authentication to it. You should probably consider using this approach. If you are already using an SDK for authentication, then chances are the creators of that SDK are working to implement this already. And you can implement it with fairly easily. On the other hand, if you have existing applications and they use the flow with the token in the URL, and as long as those risks are mitigated, then I want to repeat, there's no new threats to this, so it's not any less secure than it has been for probably since you built it. But if you're building something new, it's just probably good to follow new best practices. So how does Angular help us? Because we're Angular developers. I want to talk about this by creating an Angular authentication to-do list. So the first thing that we want to be able to do with Angular as a platform is elegantly manage authentication events. This could be things like availability of the token, it could be the login status of the user, user info, etc. The next thing we're going to need to be able to do is send the token to the API with our API requests. And finally, we want to be able to restrict access to certain routes. So that first item, managing authentication events. We have this awesome and very powerful library with Angular called RxJS, which we all know and love. One of the neat things that we can do with RxJS is create streams from callbacks. So we can take a callback and we can turn it into an observable stream. For example, maybe we're using an authentication SDK, and maybe that SDK provides us with a method to return token data from the authorization server. Now what we can do is we can use something like bind callback, or depending on your SDK type, bind node callback, to create an observable that's going to emit when the callback completes. Next, we can subscribe to this observable that we created using bind callback. And we can also pass options to the bound SDK if it wants options. And we can do that when we subscribe. Now, another thing we can do is create streams of authentication data, such as mentioned before, token availability, user info, login status. So if we were to create a stream for something like user data, for example, we can do this by creating a behavior subject. And then when data becomes available, or if it changes based on some authentication event that occurred, somebody logged in, they logged out, etc., then we can tell our stream to emit values, and then we can subscribe to it and take some action when that value changes. And those are just a couple of examples of things that you can do with RxJS to help manage authentication in your applications and with callbacks. And I'm sure that you can find a lot more ways to leverage RxJS in your applications. So if we come back to our to-do list, we learned that we can elegantly manage authentication events with RxJS. And the next thing we need to be able to do is send the token with API requests. And we can do this with HTTP interceptors. Interceptors transform requests or responses. So for example, when we call our API, we can intercept requests that are going out using an interceptor service. We can do things like attach the authorization header with our token, and then we can send that whole request on its way. So in order to implement this, if we take a look at our app routing module, in our providers array, we're going to want to provide HTTP interceptors from Angular Common. We're going to want to use our interceptor service class, which I'll show you next. And then we can set multi to true. And what this does is we can potentially define multiple interceptors, and they will then be called in the order provided. So they can do different things, and you can string them together. Now, our interceptor service might have something in it that looks like this. After the sort of necessary setup, there's an intercept function, and inside that intercept function, we can do things like clone the HTTP request that's coming in. Then we can set our authorization header with the value of our token. And then we can send the cloned request on with that header attached. Now, out of the box, there's not really a way to only run interceptors on specific requests, but we can easily just do this using conditional logic. So we can clone and modify the request based on some condition. For example, maybe the requested endpoint, we have public and private endpoints in our API, and if it's a secure endpoint, then it might have secure in the URL. We can check for this, and then clone the request and attach the header as necessary. And then if we don't need to do that, if it's a public endpoint, then we can just send the original request straight through without doing anything to it. Now, we also have the ability to create asynchronous interceptors. So we can use RxJS to do this. We can wait until data is available before we clone a request and attach the header. This can be particularly useful if you have a page where the user can authenticate from that page and make requests, but we don't want any requests to go through until we're sure that they actually have a token. So for example, let's say in our authentication service, we create a token stream. We can use this stream in our interceptor to make sure that the token is present before we do anything. So we can filter the stream for expected token values, and then we can set the token only once it's available. Now I'm using merge map here to ensure that if there are multiple requests, none get canceled by a new request coming through. So if we go back to our to-do list now, we learned that we can use interceptors to send the token with API requests. And that brings us to restricting access to certain routes. Now we do this with route guards, and route guards actually implement 3 different interfaces. Now the first interface, and probably the most common, the one that most people default to out of the box, is called canActivate. canActivate prevents unauthorized users from navigating to a page in your application. But the thing about this is the code is actually still loaded. So if you were to inspect the bundle, you could still see all of the JavaScript for that route. Now canActivate child works very similarly, only it prevents unauthorized users from navigating to all children of a specific parent. The last one's a little bit different, so this one's called canLoad, and canLoad prevents lazy loaded modules from downloading in the first place if the user is unauthorized to do so. So if we go to our app routing module, we can set up our routes, and in this example I'm using a profile component. And we can use the interface name as a property, and then it accepts an array. So we can list multiple route guards, and they're going to run in the order listed. So again, like with the interceptors, we can chain them together if we need to. Now our authentication guard is, maybe we have one that uses canActivate. It's going to implement the canActivate interface. It's going to return a canActivate function, and this function is going to return an observable, a promise, or a Boolean. Our canActivate function might have something inside it that looks like this, where access is denied based on some condition that we define. So for example, if our authentication service has a method that just returns a Boolean that tells us if the user is logged in or not, then if they're not authenticated, we can return false. We can also take some action here. So if they're not logged in and they're supposed to be and they're trying to access a protected route, then we could redirect them to a login page or pop up a login window or something like that. If access should be granted, then we're just going to return true, and this means yes, navigation should be allowed to proceed. Now the canLoad interface is used with guarded lazy loading. And we would use the canLoad route guard here to asynchronously load sections of our application for only authorized users. So it still holds true that you'd never want to put sensitive data in your app bundles, sort of regardless. That stuff belongs on your API where it can be protected properly with token exchange. But with guarded lazy loading, we get a couple of other benefits too. So we get smaller bundle sizes as well as some added protection. So our app routing module, if we're going to implement this, when we're setting up our routes, we're going to lazy load a routed module. In this example, I'm using an admin module. So the admin module is the type of thing that only certain people are going to ever need, right? Not everybody's an admin, so when the admins come into the page or to your application, then they will only receive the admin module when they need it, but everybody else who's not an admin, they'll never need it, so they shouldn't have to download it in the first place. So you're saving some load time and some application size, basically, by doing lazy loading here. Then we can add a canLoad route guard to this, and in this case, I'm going to be checking, it's a role guard, so I'm going to be checking to see if the user has the role that they need to access this module. And then I'm just going to use route data here, and what it does is this is just informing the guard what's expected. For example, I'm expecting somebody who has access to this to have a user role of admin. Now you can do this with any routing. You can use it with other guard types, you can use it with any routed module. It's essentially sort of data that's available to the route. It's just a good example of how we can apply this in this case. Now our canLoad role guard is going to look something like this. We're going to lazy load the module if canLoad returns true, right? So we want to check if they're authenticated, and then we also want to make sure that they have the expected role. So maybe our authentication service has a method called user has role. you just pass in as a parameter the expected role that you want to check for, and in this case, we can just grab that out of the route data. And then we can grant or deny access appropriately based on that. So if we come back to our list, we've learned that we can use route guards and lazy loading to restrict access to certain routes, and now we've essentially completed our list. So in the first half of the talk, I covered authentication basics and some information about best practices. And then we also talked about strategies to implement authentication in the Angular platform itself. Now, there were a lot of links at the bottom of the slides, and all of those are collected at this one location. So you can grab the slides and the resources here, which will be available. I will add them right after the talk. And I want to thank you for your time today. So thank you very much.